Okay, everyone, someone can respond whether my PowerPoint presentation is visible.
Yes, sir, it is visible.
Okay, and I'm changing the slides. Please confirm that the change of slides is also visible to you. Whether it is visible?
Slides are not changing, sir.
Okay, slides are not changing. Okay, no problem. Let me fix it.
Now it is changing.
Okay, okay, no problem. Now it is changing now. Okay, let me unshare and share it once again. I think so. Now my screen must be visible, right? Hello.
Yes, sir.
Whether my screen is visible, the slides get changed.
Yes, sir. Yes, sir.
Okay, okay. So now I think everyone must be joined, or whoever not joined it, they will join later, or might be go to see the video on YouTube, right? So now I can start. Okay,
Yes, sir.
okay. So let's start. This is the first lecture. So now I'm starting with my brief introduction and some instructions which I have usually keep during the class. Okay, so my name is Sumit Kumar. I am PhD research scholar at Department of Civil Engineering at IIT ISM Dhanbad. This is the soil mechanics course, which is also said as Geotechnical Engineering 1. It is taught by Dilip Kumar Vaidya sir at the NPTEL. And this in this course we will going to read the basic of soil mechanics. This is also known as the basic of soil mechanics. This is the 12-week class, and if required, I usually take one extra class also as a 13th class, which is also a 2-hour class. But as per schedule, it is a 12-week class. But in general, whatever course I have taken earlier, I have taken one extra class as well to clarify any doubt if remained after the 12th class. So I also planned the same way for this session as well. But let's see what happens at the end. And one most important thing, that whatever the content what I am showing over here is shared with you through Google Drive link, and that link will be shared with by the NPTEL team by me, and they will share it with you, right? And in addition to that, this video is recorded, and this will also be uploaded on the YouTube channel, and the link will be shared with you. If for any class some of you are not able to join due to any reason, you can go through the YouTube channel and there you will see. And in addition to that, this is the first class, so I think so you must have gone through the lecture of the sir. If not, that's not the problem. I'm going to discuss the theoretical concern first of all, and subsequently I will cover some problems as well, which may be helpful for you during the numericals, during the assignment problem which you are going to do, right? P no problem. So now I will start, I think so. There are many people are already here. There are 12 people are there. So now I will start, and in the between, if anyone joins, that's not the problem. And additionally, one more important instruction is that if you have any doubt in between, you can ask. But I prefer that keep your question till the end. This is the first class, so I don't think so any issue regarding in your mind. Afterwards, as assignment came, some problem may be confusing for you, so you can ask subsequently. In this class also, if you have any doubt, you can ask at the end of the class, and I have kept some questions as well, which could be helpful for you during the session. I try to keep the session interactive. In between, if I ask something, and try to answer. If you are not able to do so, that's not the problem. This happens with everyone, because this is not the thing that I know everything. I also have my limitations. I also have some doubts. No one is expert of any subjects at any point of time, so we will go in that way only, right? Okay, so now I will start with the contents. Let me see if I can minimize this so that I can see who are the people present over there during my interactions. Give me a minute.
Unmute the mic, sir.
Sir,
Hello.
mic unmute.
Oh, sorry. Sorry. I am muted. Okay. Sorry. I will restart again. And now I am audible now? Now I
Yes,
am
sir.
audible? Oh, sorry. I have started, but okay, no problem. Okay. So let's start with the basics. That is the name itself. Any name says it's a story in itself. Like over here, the subject named is soil mechanics or geotechnical engineering one. The soil, in soil mechanics we read the basic concept, the mechanics of soil, the what the soil, how the soil behaves, how the soil formed, how soil generated, how its nomenclature has been done in the different systems, in the different Indian standards, those things which we are going to read in this subject through our classes, which we are going to cover in the 12th, right? So in soil we normally read two topics like the geotechnical engineering 1, geotechnical engineering 2. In the geotechnical engineering 1 we read about the basic of soil mechanics, where we read the basic properties, shear strength characteristics and many more things, while in the geotechnical engineering 2 we read the other applications like the soil stability, foundation engineering. So over here we are going to study the soil mechanics, that is the geotechnical engineering one. So first of all, start with the origin of soils, its index property and the classification system. In the today class, if you have gone across the lecture of the sir, you have seen that in the first week and the sir has discussed these things only. So I will elaborate it over here, and at the end I have some questions, very simple questions which must be helpful for you, and I think so all of you are able to answer once we go through the session, right? Okay, so first of all, start with the agricultural and engineering soil. Basically, whenever we come across the word soil, we see that it has a huge application. Starting from the basic human needs is food, and the crops and the grains that is also generated from the soil. If there is no soil, there is no such characteristics are present, how we are able to get food? So the soil is not the building block, but also the basic requirement which is compulsory for the survival of human or organism, right? So when we see the soil, there is a top soil. The top soil is a layer of organic soil that is very thin, like 500 thick, and it is often found. So we classify over here on the basis of the few. When over here we say the organic soil, so organic soil is humus, highly organic, partially decomposed vegetable matters. And how the organic soil formed? By the decomposition of the organic matters, the organic humus get formed. When we move forward, the subsoil portion is there, that is the portion of the earth crust affected by the weathering. As we move forward, we see the formation of soil, we see the different types of formation of soil through rock, like the transported soil, residual soil, organic soil. So over there we elaborate those formation mechanics. Okay, when we come move further, we see that in the humid climate, humic acid can be formed by the rainwater using the decomposition of humus, and the acid leachage out drains, and the alumina oxide down into the lower layer, where they act as a cementing agent to form a hard rock-like material. It is difficult to excavate and does not soften when wet. Okay, so don't confuse over here. We will discuss in elaborated form the three form, which is the like the residual, transported, and organic soil. So you will understand far better. This is the basic definition. Basically, agricultural and engineering soil basic definition is there. Now you see from here, the figure has been shown. So over here you see in the right hand side the soil material is shown, and in the left hand side the soil horizons are presented. Over here you can see at top humus, the organic soil which is mentioned over here is shown, while in the the point A, the zone of leaching or the subsoil soluble salts topsoil is given. Okay, here a point came, a word come leaching. So what do you understand by leaching? the soluble salts are there. So in leaching, if you have seen somewhere, specifically if you have gone in a village or some places like that where the heavy rainfall takes place and the um, marshy lands get created due to high rainfall, almost if you say in Hindi, dal. So that type of condition get generated at some places due to high rainfall or maybe flooding. Over there you see sometimes the vegetations, the growth of the crop get declined due to the this happens also due to the excess irrigation. In the irrigation also, when the large amount of water get and drained out at the specific fields, at the specific irrigations farm, over there also due to the presence of water for the lifetime, the conditions, marshy land condition get generated, that is eradicated with the help of process of leaching, in which the clean water is supplied, that will be replaced drained out from there, in which the soluble salts are get separated. That is the different topic, but the leaching requirement, when you read irrigation, the leaching requirement word you came over there on that, and the leaching requirement is leaching required water required for the leaching process is also added when we talk about the conjunctive irrigation requirement or the field irrigation requirement, when you go to discuss in the so irrigation topic, irrigation engineering, right? Now over here the zone of the accumulation of salt is variable, whether weathered parents material bedrock is variable, and the gradation contact and the fresh parent material is shown. Okay. Now, moving forward, we see that the soil is the soft geological deposit from the subsoil to the bedrock. In some soil, there is a certain amount of cementations between the grain that affect the physical property of soil. If this cementation is such that the hard rock material has been produced, then the material must be described as rock. A rough rule is that if the material can be excavated by hand or the hand tool, it is soil. Okay. So if you go to the some layman like who have no knowledge, no expertise, and you say that you have to tout him that what is soil, basically everyone know that what the soil is, but in a rough estimate we say that if the material can be excavated by hand, basically if there is at some places a very hard rock is there, so you cannot excavate with hand, but if the soil is there, that organic matters, the soil created by organic matter is there, or the residual soil is there, or the alluvial soil is there, or maybe sand is there. If you go to the bank of the river or the ocean, you see that the sands particles are over there, which you can excavate with the hand only. So that is the basic definition of soil. In the layman language, we say that a material that can be excavated by the hand or the any hand tool, like whatever we used in day-to-day life, is the soil. Moving ahead, when we talk about the engineering definition, as we are the civil engineers, so the definitions need to be understood by the widespread perspectives. In that, we say that the geologist classifies the all item of the earth crust as rock, whether hard or soft deposit, and the civil engineer consider rock and soil separated, right? Basically, if you have came across this topic earlier, you must know that the rock mechanics is a subject in itself. Over there we specifically study about the different properties, considerations, testes, and the various standards are also provided for the rock separately, which is considered different from the soil in some way or the other. But as we move ahead, we see that the formation of soil from the rocks over there, we see that how the formations of soil takes place from the rock. Okay, so we are moving ahead. Over here you see the rock cycle. So this rock cycle is visible over here. You see that first of all the gases are there. Basically 4.5 billion year ago the gases are there in the earth. Then it going to be cool, and after cooling basically you know that the earth is established not as it is visible today. The 4.5 billion year ago over there, there are only gases in the atmosphere. After that it converted into molten magma after cooling. Subsequently it converted into igneous rock, and when the igneous rock after weathering, the weathering process which we are going to do it, the residual soil form. After that the residual soil under the heat and pressure get converted into the metamorphic rock. Residual soil also on weathering and transportation formed the sedimentary deposit, while the metamorphic rock on the weathering and transportation also converted into the sedimentary deposit. Subsequently the metamorphic rock get also formed from the sedimentary rock by the consolidation and the cementation under the heat and pressure. Uh, and the sedimentary rocks um, by weathering and transportation and compaction and cementation also change its property. As we move ahead, we see that the some of the chemical property get changed, uh, or the property of the parent rock is itself in the residual soil. So this is the over and all rock cycle by which the different characteristics of soils get formed over the period of time. Now we will go ahead and see it and look it in detail in the definition form. Okay. So now see, the rocks are the made from the various types of minerals. Minerals are the substance. Basically, mineral is nothing but the substance of the crystalline form made up by the particular chemical composition. The main material in the rock include the quartz, feldspar, calcite, mica. The geologists classify all rocks into three basic forms, as I have said earlier also, and in the rock cycle you also seen that the igneous, sedimentary, and metamorphic. I will show it again. You see over here the igneous rocks is there in the top right corner. You can see the igneous rock is written. In the middle right, the in the bottom right, the metamorphic is written, and the sedimentary deposits are also mentioned over here. And the metamorphic rock get converted into the sedimentary deposit by weathering and transportation process. How it will take place, we will see in the definition. But these are the three basic groups which are classified by the geologist. uh, right. Now see, he started with the igneous rock. So the igneous rock, they are the rock having become solid from the melted liquid state. As you see here, over here also in the this figure only, when the molten magma get cooled down, it converted into the igneous rock only. So this definition that these rocks has become the solid from the melted liquid get justified. Now it is also in the two forms, that is the extrusive and intrusive. What do we mean by that? The extrusive igneous rocks are those that arrived on the surface of the earth as a molten lava and cooled. And basically, you have seen that the volcano-like thing. There are always in some time you see that this volcano get active. Not in Indian perspective. In India, there is no such dangerous active volcano at this point of time, but specifically in the Europe or maybe some other part of the Asian continent also, these are came in news. So when the volcano burst, some of the solid material flow out from that. So in that perspective only, the uh, thing which arrived on the surface of the earth and get cooled is the extrusive igneous rocks, while the intrusive igneous rocks are those that are formed from the magma, molten rock that forced itself through the crack in the rock bed below the surface and solidified there. Basically, it solidified in itself. It does not in extrusive igneous rock. Those material blown out and fall on the surface of the earth. Over there, they cool down and then converted into the solid. Basically, the magma is also in the form of dense liquid itself. When it get solidified by cooling, it is converted into the rock. While in intrusive, it's get cooled over their base only. So example are like granite. As you know, the granite is a very strong material. You have gone seen across in some of the constructions for houses, in kitchens, some places the granite is used also as a decorative rock, right? And the basalt, gabbro are the some of the other example of the igneous rock. Now, see some of the characteristics which we have discussed, the three name granite, gabbro, and basalt. So the granite is a coarse, the texture, the grain texture of granite is coarse, and granite and gabbro is coarse while the basalt is fine. Similarly, in color also, the granite is light gray while the gabbro and basalt is dark. Now talking about the composition, which is the most important part. In granite, mainly the quartz and the ortho orthoclase mixed with the biotite and muscovite. These are the name which is there in their composition. Similarly, the gabbro is formed. Gabbro and basalt both are formed mainly of the plagioclase and the proxins, right? So these are the things which you need to understand. Basically, the some of the questions, some of the multiple choice questions get formed, that what is the composition of the granite, what is the composition of basalt. So that type of problem are there. Some multiple choice question also get created, citing the colors and the grain textures of the different type of rock. Some questions could also be framed in this form, that which of the following are the igneous rock. Over there, the granite or basalt or gabbro is one of the options, and some other options are of the metamorphic or sedimentary rock. So these types of problem get framed from these slides, right? Moving ahead, now as we discussed the igneous rock and how it formed from the molten magma, cooling of molten magma. Now we move to the sedimentary rocks. So those sedimentary rocks formed by the weathering process, we have also seen this from the rock cycle. So the weathering reduces the rock masses to the fragmented particle, which can more easily be transported by the wind, water, and ice. When uh, dropped by the agents of weathering, they turned into sediment. Now you see that how the weathering takes place. So we will know that the river like the flowing river, the water, air, and wind, uh, these are the agents which take the soil particles, which break the rock particles into the finer particles. As we know, as you also aware that you see that when the soil particles is carried away by the water course, over there the particles are very smooth and normally spherical in nature. Okay, that is the part of the next chapter, so we will see over there. But the weathering reduces the rock mass. How it reduces the rock mass? As it break the big particle into the small particle, as it get converted into a small particle, it is easily get transported by the wind, water, or ice. Okay, what I have said earlier, that is written over here. When dropped by the agents of weathering, they are termed as sediments. That's why These are called sedimentary rocks, and these sediments are typically deposited in the layer or the beds called strata. Strata means in you also as we go ahead, you came across by the term named stratified soil. So stratified soil is nothing but the soil deposited of the different characteristics in the different layer. As we move ahead, we will see talk about the specific weight, water content. So over there we see the specific gravity of soil. Over there we see that there are different specific gravity for the different type of soil. Like for the organic soil it is less, or for the inorganic soil it is different. For mm, the for the different soil characteristics, its property get varied. So when it get deposited into the different layer, like the organic soil layer at the top, in the between inorganic layer, or maybe some soft layer is in between the two of the hard layers, so they get formed the three strata, right? I think so I need to draw some one thing to state the stratified. Okay, so I think so my pen is like over here. You can see I have drawn these three layers. This is layer 1, this is layer 2, and this is layer 3. Okay, so at this layer the soil characteristics are different. Suppose I classify in the form of gamma. Gamma only. Gamma is nothing but the density. Okay, wet density. So suppose over here gamma is 16, and over here, this is just for example, not the actual case in any way. And over here the I have specified gamma only. The other shear strength characteristics like the cohesion, angle of internal friction also get varied. You are can also able to calculate the modulus of elasticity as well, that get also varied. But just for example, I am explaining that what do we mean by the strata in stratified soil specifically. So in different strata, its characteristics, suppose there is a very weak layer in between, and then again below the gamma gets 70, right? So these three layers are divided with the three different property. So this is said to be the stratified soils. Okay, so the example of these are shale, sandstone, and chalk. And again, we will discuss their characteristics, like as we have read in the igneous. Over there the granite and basalt and gabbro are there. Over here the three limestone, sandstone, and shale is there. The group type, grain textures are mentioned over here. As you know, the limestone is very much important. If you have read the course of the building material, over there also you see in the cement formation limestone is important. In the brick formation limestone is very much important. As we see now, the soil is the building block. So from cement to the brick to the every aspects of any construction work, soil is important. Apart from that, any of the structure which is present in the world, either it is in the world, either it is the roadway, railway, or any bridges, any building, any multi-story structure, everything is situated in the soil. So the first thing when we go across uh, any of the project, we say that give me the soil report. And soil report is nothing but the basic characteristics of soil which we are going to study in this subject, right? So over here the brief descriptions are also mentioned over here, so I don't think I need to read it over here. You can go across. I will share this PDF, and if any doubt is there, you can ask me in the next class. So I will move to the next. Next is the metamorphic rock, as it is mentioned earlier, and that the igneous, sedimentary, and metamorphic rock is there. And the metamorphic rock, the process metamorphism through it is formed through the process which is said to be metamorphic through the high temperature and pressure. If you have remembered the rock cycle over there, when the arrow is mentioned, temperature and pressure is mentioned, and I have said earlier that under the high temperature and pressure acting on the sedimentary or igneous both. If you have remembered the rock cycle, the arrow come out from the sedimentary as well as igneous rock, produces the metamorphic rock, and the original rock undergo both the chemical and physical alteration. Okay, now understand this, the chemical and physical alteration work very important, because if the physical changes takes place, then the core characteristics like the properties of those material doesn't get altered. But if the chemical change takes place, then the property get changed up to a high extent. The property of the parent rock is not as it is for the formed metamorphic rock. Over here also the examples is slate, quartzite, and marble. As you must be aware about that. Slate is also one of the sorry. Okay. So over here again the example and characteristics are mentioned over here, and like the texture of slate is fine, marble is medium to coarse, so that is mentioned over here. And the similar type of problems as I have discussed during the igneous rock get formed from here as also, that what are the texture of these type of rocks, and these options are mentioned over there, so you have to solve accordingly in your assignment problems, right? Now we come across for the soil formation from the rock. Right now we have read the three types of rocks which we have with us, that is the igneous, that is the igneous, metamorphic, and sedimentary rocks. Now we will see the formation, the agents which bring these from one places to other places to get formed in the way which they look alike, right? Now first of all start with the soil. The action of the frost, temperature, gravity, wind, rain, chemically weathering are continually forming the rock particles that eventually become soil. So there are the three types of soils when considered modes of formation. So first is the transported soil, second is the residual soil, and third is the organic soil. So before going ahead, I will explain you over here only. Then as we go ahead, you see that thing. Okay, so I will take a pen again. Okay, so in the for the transported soil, and the agents are nothing but I think so you are well aware that the agent could be water, right? Okay, I will save only, because if I write it will take too much time, and that doesn't require us. Okay, in the transported soil, the moving agent is water, wind, rain. Normally the water, wind are the main agent which transport the soil from one places to other places, but some other agents are also there. In on the other hand, in the residual soil, the soil get formed, get break out from their soil and reside at their own place only, while the organic soil is formed by the decomposition of the organic matter itself, and their strength is relatively low. As we see the soil classification systems over there, you come to know that how if you are mild aware about the soil classification, over there we say the E line, the equation is like 0.73 into WL minus 20, where WL is the liquid limit. So okay, so we will discuss over there only, because if I say at this point of time, if you are aware, you will understand. Otherwise, it will be missed out, right? Now see, we will go one by one. We started with the transported soil. So in the transported soil, we say gravel, sand, silt, and clay. If you are well aware that there are the, when we say the soil, we say gravel, sand, silt, and clay. In the gravel are the large size particles of soil only, and usually have size greater than 4.75 mm. while in the sand its size varies from 4.75 mm to 75 micron, I guess, and below that the silt and clay came across, right? So the most of the soil are transported by water. As you know, the earth consists of a majority of the water only, and those are normally the rivers and oceans, but the water get formed near the lake and the found are also named differently, like the soil formed near the lake water is called lacustrine soil. You will go ahead, we will go ahead and you will see those discussion as well. Okay, so as the stream or the river loses its velocity, it tends to deposit. You see, many of you might be come from the places where you have seen the river or the flood like condition over there. Then the flood came. If you are not aware also, you have need to understand that when the flood came, it brings the large amount of sediment, silt or clay like particles, small particles, and it deposited. And I have seen this basically in a flood when the water came into my house. Huh. And I am over there, and I see when the water flows out, the large amount of soil deposits are get extracted in my house. That is very fine, like the silt and clay sized particles, and that usually there in the uh, rivers when it's come in the form of flood. And it also bring the very high quality of soil particles with it. You usually see normally when over the places where the problem of flood is there, when the flood came and it crosses over there during the subsequent seasons of farming, the crop growth get very well as well. If you are aware, you see, because the quality of soil it bring with it is very good for the farming process as well. Okay, so I get deviated. I will come to the point only. So as the stream or the river loses its velocity, it tend to deposit some of the particle that it's carrying, dropping the larger or the heavier particle first. But as I have said that during the flooding process, that not the case. During the flooding process, the embankment or the portions which used to constructed to stop the water get break down and the water flow in the free flow direction. So in that case, it's bring all the soil particle with them and get deposited over the plane through which it get crosses, right? Hence, on the hence on the higher reaches of the river, the gravel and sands are found, right? Because the when the velocity gets slowed down, earlier it's drop the heavier particle. Heavier particle is what? Gravel or sand, while at the lower part the silt and clay are present, as it is understood by everyone that suppose when a river came out from a specific places, initially it dropped the larger heavier particle, and that larger heavier particle is nothing but the gravels and sand particles. As it move forward, now it carries the small particle with them, but as the velocity gets down during the low flood time, the where the river carries low water itself, it drop the heavier particle as well, because at that velocity those particles carried by the river is not possible, hence the small particle get drop out. And usually you see that the river flow out some of the mountains, uh, you have studied the river basin in India in the geography in your 10th or 12th classes. So over there you see that the river flew out from there to the rock particles it carry from there, and the heavier with the flow of water, these particles break down into the small particles and ultimately result in the very fine particles get deposited on the ground itself. at the very lower end, while the heavier particle like the gravel and sand get deposited at the higher end. But that not only the case. During the low flood time, those heavier particle which get deposited in the upper trenches also get carried away and moved to the downstream side, like in the field for the deposition. Okay, now over here, okay, the image also get cleared as it is discussed. The flow start, and when the water flows out, it's first of all deposited the heavier particle like the sand and gravel. Afterwards, the silt and subsequently the clay deposits get formed. Uh, in any river course, like any hydrological engineers, hydrological experts coach and test the property of soil characteristics over there, they found that this type of scenario only. Okay, now we move ahead and we see in the transported soil loess. Loess is nothing but in the arid part of the world, wind continuously forms a sand deposit in a ridge. The sand particle in this ridge has been more or less rolled along and invariably rounded and relatively uniform in size. Okay, you have seen in somewhere or the other, or maybe in any movies also, the sand dunes comes, right? So over there, the sand, the storm of sand flows out over as which storm get boiled. It bring the sand particle from one places to other places, and it get deposited at some other places, and in during their movement they rolled over one another, resulted in the uniform size spherical particle in general. They are the light brown wind-blown deposits of the silt-sized particle known as loess, and are often encountered in the thin layers that the particles having sometimes travel considerable distance, as I have seen during the wind storms. And this is usually happen in the places where the arid part of the world. You have also seen in some of the countries, some of the continent, the wind farms are there through which the blades get moved and electricity get created. So those places, those arid region, this type of formation of soil takes place. Now moving to the residual soil, from transported to residual, now we are moving to residual soil. So these soil are formed in situ by the chemical weathering and may be found on the level of the rock surface where the action of the element has produced the soil with a little tendency to move. The residual soil can also occur whether whenever the rock break up rate exceeds and the rate of the removal. If the parent rock is igneous or metamorphic, the residual soil size ranges from silt to gravel. Okay, now I will explain it differently. Suppose at a specific place the rock is there, and in that rock some water get trapped, and during the cold season it's freeze out, and during the summer season it's get result in the water. So due to that process, or due to some chemical action, some other chemical reactions, it get drained off, rock get part into the small particles, and those particles get retained over there only, that have not tendency to move around, is said to be residual soil, right? Now, moving ahead, the laterites are formed by, this is also the residual soil formed by the chemical weathering under the warm and humid tropical condition when the rainwater leach out the soluble rock material. Okay, I have earlier said weathering and freezing and thawing. Over here, you see that when the rainwater leach out from the soluble rock material, leaving behind the insoluble hydroxide of the iron and aluminum, giving them their characteristics to the red brown color. Over there the laterite soil get formed. right? Now, moving to the third soil, the formation of soil through rocks, which we are reading over here, in which the third is the organic soil, and this soil contains the large amount of decomposed animals and vegetable matter. I have seen this earlier, na, in the very first slide when these names are written, that these are formed by the decomposition of organic matter itself. So the organic that is what animal and vegetative matter. They are usually dark in color and give off distinctive order. Obviously, if any of the material decomposed by the organic process, they give very bad order, and the deposits of the organic silt and clay have usually been created from the river or the lake of sediment. Peat is a special form of organic soil and is dark brown, spongy material that almost entirely consists of lightly or fully decomposed vegetable matter. It exists in one of the three forms which is we are going to discuss ahead. So what are the three forms? So three forms are uh, fibrous, pseudoplastic, and amorphous. Okay, so we will see that what are these three types. Okay, so I think so. Okay, we will go ahead with it. After the organic soil get completed, we will take a 5 minute break and then move forward for the next 1 hour class. Okay, so the fibrous is the non-plastic with a firm structure, only slightly altered by decay, and the pseudoplastic peat is in the form still has the fibrous appearance, but is much softer and more plastic than the fibrous peat. The change is due to the more prolonged submergence in the airless water than decomposition. Basically, this is the theoretical thing. Need, nothing is more fancy in this. Like in the amorphous, with this type of pit decompositions, the original fibrous vegetable structure have been destroyed so that it has virtually become an organic clay. Subsequently, the pit deposit occur extensively throughout the world and can extremely create trouble when encountered in the civil engineering work. Basically, if you have seen that any places the pit deposits get found, the construction work going over there is going to suffer for sure, right? You now we will talk about the granular and cohesive soil, but before that, I think okay. Before that, I think we need to take a small 5 minute break, and we will start from this is 4-2. We will start from 4-7, 4-7 or 4-8, right? So here we are going to take a 5 minute break. Okay, everyone. So I think so my screen is visible. Hello, everyone. Anyone can respond whether my screen is visible.
Yes, sir.
Okay, okay. Thank you very much. So now we will move forward. I think so 5-minute break will be enough. Okay, so I am starting. Okay, so we are talking ahead. When we closed, we talk about organic soil like amorphous and pit deposit. Now we are moving with the other engineering soils characteristics like the granular and the cohesive soil. So as I have seen that we reached around 29 or 30 slide only, and we have many more slides to cover. That's not the issue. If some questions which I have created, I want to discuss it today itself. But if not possible, I will share it in the entire PDF with you, and you will go across that problem. And in addition to that, I will suggest basically what we are reading today is the theoretical concept. So this is more or less what we read. These are the points only. That is not need very explanatory consideration. Basically, if I say that this is the silt, this is the gravel, this is the property, this thing only. But as we move ahead, we from the subsequent classes, when we go into more detail over there, we rate the characteristics like the water content, void ratio, porosity, specific weight in the different conditions, like the saturated well, saturated bulk unit weight. The different things over there, the discussion is more promising and more engaging. Over here, as I also understood that what I taught is not very much engaging, but as you see, as I move ahead and we cover the entire content, afterward I will give some questions. This class may be move further by 15 minutes, maybe it will end by 5:15. So I think so that will be okay for everyone. Right now, basically, we have also started 10 minutes late due to some technical reasons. First class is there. I am not able to share the screen very easily. So that's the problem is there. So this class may be carried forward up to 5:15. So over there, I have created some problem. I have put some problem in this slide only. So we will try to solve. As you see, when we read the entire content, you can easily able to solve this. Okay, so that's it. And now we will start. So we are talking about the engineering soil, talking about the granular or cohesive soil. So in the geotechnical engineering, classifies soil as the granular or cohesive soil. So you know that the cohesion, when we see cohesion, that is the they are the two shear strength parameter. That is the cohesion and angle of internal friction. Right. The cohesion is the property. Cohesion is that characteristics which we calculate from the cohesion and angle of internal friction both, which could be calculated from the triaxial test, shear strength test, and some other tests are also there through which we calculate, which we are going to read at the end of this subjects only, or maybe I'm not aware at whether it is covered in this subject or maybe in the geotechnical engineering too. But as I remember, it is covered at the end of this coursework only. Okay, so first of all, talk about the granular soil. So granular soil sometimes referred as cohesionless soil. Why? Because these are the soil which have very less cohesion. And one important point you need to understand that the cohesion and angle of internal frictions both have the different characteristics with one another. In the granular soil, uh, okay, first of all, I read this content, then I will add on my own points. Like the granular soils are the formed from the loose particles without the strong interparticles forces. Yes, absolutely. While the cohesive soils are made from the particles bound together with the clay mineral, and the particles are flaky and sit like and retain a significant amount of adsorbed water on their surface. The ability of the seed-like particles to slide relative to one another. Okay, so this is the definition. Now I will add some other point in this. Like in the granular soil, the normally you see the sand. You must have seen the construction work over there. The sand is brought out. So over the when you pick the sand in your hand, it is very, it has no stickiness in itself. So that is the cohesion soil, that is the cohesionless soil, that is the granular soil in itself. While the other soil characteristics, if you are if you have seen any construction work at that places, we bring out, we see that the soil is there and that is quite sticky. If you, we have, as we move ahead, we see some test as well, in which how we understand that this soil has what type of characteristics, how we classify whether it is the granular soil. We, granular soil we classify as the gravel and sand, while the cohesive soil we classify silt, clay, and many more things. Highly compressive, low compressible, intermediate compressible. Those classification systems are discussed in this class only as we move ahead. So those two characteristics, in the granular soils, there is no stickiness in there, and their interparticle attraction are relatively weaker, while in the granular soil, while in the cohesive soil it is quite strong. Right. Now see, the soil versus the other engineering material, when we see, so, so what is the difference between the other engineering material like steel and concrete? So the steel and concrete are the manufactured and can be produced with the desired strength and stiffness, and the quality can be monitored, right? We make the different characteristics of steel, like mild steel, SYST steels, different type of steels, different characteristics, and that is monitored and that is well controlled. In concrete also, if you have gone across the course of building material or maybe RCC, you see that the M20, M25, M30 different grade of concrete. If you have read the pre-stress concrete, they studied the pre-stress concrete, their strength, their characteristics are also well controlled and very easily manufactured according to our strength. Like for the railway, the different, in the railway, the grade of concrete is used is also developed by the Indian Railway itself, which is also of very good strength. So that is the controllable and manufactured. But while we cannot manufacture, as it is written over here as also, formed naturally, properties are mostly not known and depend on the many factors, and there are the no control over its quality. Absolutely. In the soil, we have no control on its quality. It is formed from the natural process, as we have seen, whether it is igneous metamorphic or organic sedimentary, or in the on the other hand, formed by the different agents through which it formed the residual, transported, or the organic soil. So there are no control over there, but we can modify its characteristics when we, as you read these two subjects like the soil mechanics or the geotechnical engineering one, moving forward you will read geotechnical engineering 2, then the soil improvement techniques is also a subject in which we read that okay, if we are going to construct some structures at the place where the soil characteristics is very poor, so the first remedy is to that to remove this soil and bring some better soil over there. But that not always possible. Suppose we are going to construct some work over here in Dhanbad itself, as I am sitting in Dhanbad, and suppose the characteristics of soil is very poor, there is no construction possible over here. But the first solution is to rectify, is to change the soil itself. But if the good quality of soil is available in Delhi or maybe Tamil Nadu, so is it possible that we bring from there to here and then replace that soil, and afterwards some construction work will go on? That will take huge time, and that is also not possible in a very feasible manner. So we will improve the characteristics of this soil only, so that it is suitable to sustain the specific amount of load which is required for the construction process. So that we will read in the soil improvement technique, which is not the part of this subject, but in this manner, in this flow, we proceed in our subjects, right? Now, the soil, talking about the soil characteristics, the soil characteristics are permeability, compressibility, and shear strength. As I have said earlier, now permeability. Now I will say that there are the four soil characteristics, like the granular soil. In granular soil, the gravel, sand, silt, and clay. Okay, so in the gravel, sand, silt, clay, the permeability is very much high in the gravel, afterwards sand, subsequently the silt and the clay, right? Why? Because in the gravel, the large size particles are there. As we move ahead, we also read about the well graded, poorly graded soil. Over there, and the gap graded is also one of the word which you come across. So how you come to know that this type of characteristics is there? So for that we do the sieve analysis, that is we also going to uh, interact study in this class only. So the in permeability, if suppose I am giving an example, the gravel are the large size particles. Suppose you take um, uh, you take a tub, you take a bottle, very big can, very big bottle, which may be of glass or maybe plastic, and you bring a very big particle which have the size greater than 4.75 mm in that, and do a small pin, take a pin and make a small hose in upside and downside. Okay, and take two that type of bottles only, and in one you fill the gravel size particle, in other you fill the sand size particles. Now take a glass of water and drop into the container in which the gravels is there. You see that amount of water flow out very quickly as compared to when you drop that water in the sand. Subsequently, again take the clay soil in that container only, or the similar container only, and we drop the water. You see that the water flow of the flow out of water takes place very much large time. So in that manner only we define the permeability, that how much permeable, how much easily it allow the water to flow through them, right? Now similarly, the compressibility is nothing but the characteristics of that soil particle that is get compressible, that is also defined as delta H by H equal to delta V by V, where delta H by H is the change in its height by compressing those soils. So when you see again the sand, clay, and gravel, their characteristics also get different. Similarly, for the shear strength, the shear strength characteristics is primarily governed by the angle of internal friction in the cohesionless soil, that is the granular soil, while in by the cohesion for the cohesive soil like the clay or the silt, right? Okay, so that we will see. Now we come across the sand, silt, clay, and their field identification. In field, how we identify whether it is a sand, silt, or a clay. Basically, gravel is the large size particle, so you will identify. Normally, boulder is also very large size particle. Boulder is basically larger than the gravel itself. So the when we talk about the particle visibility, though when we see the visibility, the sand is a individual particles are visible. Like if you see for the, any construction work, when you brout out the sand, you can bring the small particle, see the small particle itself. While in a silt, some particles are visible, but in a clay, the no particle is visible as an individual. Similarly, for the sand, the it exhibit dilatancy. Dilatancy is the property of change in how much it change in the volume, or maybe something like that. In silt also exhibits that dilatancy, but in clay the no dilatancy is there. Basically, dilatancy angle is a word which is defined. How it is defined? Okay, we will discuss that as it's come ahead. While in the dry handling process, when we talk about sand, so easy to crumble and falls off hand when dry. As I have said already, that when you take the sand, it's flow out from the hand very easily. While in a silt is also easily crumble. Basically, when you make a rope and crumble on glass or maybe any solid surface, easily crumble and dusted off hand when dry. While the clay hard to crumble. Basically, when you say clay, it has a high plasticity, so ये crumble very difficultly and stick into hand, हाथ में चिपक जाएगा. Basically it stick into hand. Similarly, when we talk about the sand, it feels gritty, silt is rough, and clay is smooth. Basically clay is smooth because it has high plasticity. Okay, this is written also that in sand no plasticity there, silt some plasticity, but clay has a plasticity but very high plasticity, right? Okay, so as I have said earlier that how we classify the soils, different soil characteristics are there. We have discussed different things, but how we classify that, whether it is a gravel, sand, or silt or clay. So for that, we have to see that the what size of particle is there. So in Indian soil classifications, the mechanical analysis takes place, the sieve analysis takes place, in which, as is shown in the figure right hand side, you can see that we take the sample which need to be sieved, and the large size all the soil particles are put it in a pan as shown over here. Okay, let me take a laser point. You see, over here we fill the sample soil which we need to sift, and we bring it over here. And the sieves are arranged in this fashion that the 4.75 mm sieve is at the top, followed by 2 mm, 1.1 mm, 8 mm, 600 mm, 435 mm, 300 mm, 150 mm, and 75 mm. At the end, there is a pan is also there, in which there is no percolation, no hose is provided. Basically 4.75 mmc means the percolation in the sieve is of size of 4.75 mm. When we sieved it, we see that the particle flow in the downward direction. The particle larger than 4.75 mm get retained over there. Follow subsequently the 2 mm particle get retained over here, and 1.18 mm in this. At the end, in the pan, the particles smaller than 75 micron get deposited. Now, how the classifications takes place, how we define. So we see that what are the size of the particle that is greater than 4.75 mm. If the particle greater, there is the two different classification. First of all, see that the particle greater than 75 micron is more than 50%. This is 75 micron. If particle greater than 75 micron is more than 50%, then it is a porous material, right? And if the particle greater than 50% is in this pan, then it is a fine material. If the more than 50% is above 75 micron, then we will see whether the gravel fraction is more or the sand fraction is more. So for that, we see that the particle greater than 50% in the 4.75 mm or less than. If the particle greater than 4.75 mm retained retained over this sieve, then we see that it is a gravel. But if the amount of particle retained above 75 micron, in that only, if the greater fraction of particle, if the less fraction of particle retained on the 4.75 mm sieve, then it is said to be sand. Subsequently, on the basis of that, we classify. So that is also going to discuss in this session only. So we will go ahead. I think so. Up to this sieve things is clear to everyone, or any doubt? If anyone have doubt on this, can ask this point of time, I will discuss it again because this is very much important as we move ahead. Anyone have any doubt? I think so, no. Okay. So I think so this sieve analysis and the term which I have discussed is very much clear to everyone. Okay. Okay. I think so. So I will move ahead. Now you see that over here the example is also mentioned over here, in which as I have said earlier that the some particles are retained on the 4.75 mm sieve. So the particle retained on the 4.75 mm sieve is mentioned over here. Similarly, the basically over there the 2 mm sieve is retained, but 2.4 mm, what that's just for example. So the particle retained on this 2.4 mm weight retained is mentioned over here, and ultimately in the pan how much retained is retained. Afterwards, the cumulative weight is written. Cumulative weight is nothing but first of all here 11.02. In this 30.45 plus 11.02. Over here 41.47 plus 46.26. And in this manner, we have written the entire weight. Hence, the total weight we have taken in the above topmost sieve for the sieving is the 300 gram. Right. Then we see the cumulative percentage retained. The cumulative percentage retained is 3.67%. So the percentage final is 100 minus 3.67, that is 96.33, 86.85, 76.76, and so on. Right. And this is a chart through which is plotted on the basis of this sieve analysis, the value of percentage by weight retained, and over here the size, and on that also the cohesive and cohesionless soil is mentioned over. We will discuss it once we start our problem sections as well. Now you see there are some important terms over coming ahead. What are those terms? So those terms are coefficient of uniformity and coefficient of curvature. And coefficient of uniformity and coefficient of curvature is also very much important because the coefficient of uniformity and coefficient of curvature is used to find the to classify the soil as well. So over here the coefficient of uniformity is D60 by D10. So D60 is the D60 by D10, while the CC is the D30 by D10 into D30 square by D60 into D10. So D60 by D10 is the diameter above which the 60 sorry 60% of the particle retained, and similarly for the D10, D30 as well. Okay. One of the important thing I want to mention over here, for the well graded soil, the CU value should be lie in the range of 1 to 3, while for the well graded sand, CC value should be more than 4, and for gravel it should be more than 6. As I recall, maybe for CC I may be mistaken, but for CU its value should lie in the 1 to 3. We will see. I will see and let you know that CC value. But CC value is greater than 4 for gravel and greater than 6 for sand. That's it. That's it. Okay. Now see. Now we talk about the consistency limit. Basically, liquid limit, plastic limit, sinkage limit is very much important, because that is also very much important in the soil classification system. As you aware that the soil is classified when it is a fine soil. It is based on the liquid limit only. That's range is lies into 0 to 35, 35 to 50, and 50 to greater than 50. On that basis of low compressible, high compressible, or intermediate compressible, it is defined. We will see. Now talk about the liquid limit. The boundary water content between the liquid state and the plastic state is called the liquid limit. And I think so that's one diagram is there. Over here you see the state of consistency of cohesive soil is shown. You can see that on the x-axis the water content get increased and the soil volume get changed. First of all, I will explain over here, and then we go to the definition again, and then you will understand very easily. You see, in the shrinkage, below the shrinkage limit, the water, when we increasing the moisture content, that is nothing but the water content. When we are mixing the water with the soil, there is a no change in the volume. What is the reason behind that? There must be some reason that suppose we have a glass of water and we are adding again water in it, and there is no change in volume takes place. Is it possible? No, it is not possible that we are adding a specific amount of water in a container which is filled with, suppose 300 ml of water is kept in a container, and we are mixing the 200 ml of 20 ml of water in it, and its volume remained 300 ml. It is not possible. Hence, what is the criteria that till the shrinkage limit there is the no change in the volume takes place? There must be some reason. So over here, when the water is added up to the up to the point where the volume doesn't change place, over there the void present due to air is replaced by water. At shrinkage limit, the soil get completely saturated. Now the mixing of water result in the increase in the volume. Hence, the shrinkage limit is that limit at which the soil is fully saturated. Afterwards, when we add the water, its volume get increases with the increase in water content. And the first of all, the plastic limit is reached, and the soil characteristics between the plastic limit and the shrinkage limit is said to be semi-solid. Why? And the characteristics between the liquid limit and plastic limit is the plastic solid. Subsequently, if when the water content get increased and go beyond the liquid limit, it become viscous, it become almost liquid, it start flowing. Okay, I think so the thing will be understood by you. Now you will see the definitions. So definitions say that the at the liquid limit is the boundary of water content between the liquid state and the plastic state is called the liquid limit. The plastic limit is the boundary water content between the plastic state and the semi-solid state, right? That the in definition in that way only. While the shrinkage limit is that limit where the water content at which the soil reaches its maximum volume, reaches its minimum volume, keeping fully saturated. As I have said already, that at this point of time it is fully saturated. The void, the air void present is replaced by the water. Hence, the change in volume doesn't take place from this point till the shrinkage limit get reached. Subsequently, we see over here the physical state that the for from 0 to shrinkage limit it is a brittle solid. From shrinkage limit between plastic and plastic limit it is a semi solid, while from the plastic liquid to liquid limit it is a plastic solid. Subsequently it converted into liquid only. Water content is shown on the x-axis and its characteristics is variable. Over here, some graph is also presented in which the stress strain is shown, and when the water WL liquid WL is less than PL, WL equal to PL is shown over here, and that is based on that only. But this we will discuss later because explanation of this is not present over here. Okay, so in the liquid limit test, the test is also available for the liquid limit, in which we use the Casgrande apparatus, and I think so. In you, if you are students who are in the engineering college, you must have seen this liquid limit test apparatus, Cascandre apparatus, in which if you are able to see, and this picture is not fully viewable, but if you are able to see, there is a handle shown over here, which is moved at a rate of I don't recall at this point of time, but at some rate it is moved, and the soil paste is kept over there, and it is allowed to, it flew out up to 12 or half inch. At that point of time, the soil is taken and the water content is calculated, is the liquid limit. Okay. And and the liquid limit and number of blown factor is drawn. Similarly, for the plastic limit, we take a soil and we make on a glass. There is a glass is there on which we roll the shape, and the position till which it get crumble is on that content, on that water content we test the water content, and that is said to be plastic limit. Subsequently, the shrinkage limit test is also take place in that manner only, but over here the complete thing is not viable. I will explain this again in the next class. Basically, this test is very much easy and very much easily understandable, but currently in my slides I am not able to show those things very easily. So in the next class I will take the entire process one by one so that you easily understand these tests, right? Okay, so in a shrinkage limit, weight of water by weight of solid only, and ये W1 minus WS minus V1 minus V2 into gamma W by WS is the shrinkage limit. This thing is you're not able to understand at this point of time. Once you understand the water content, and over there the WS is also, the shrinkage limit is also defined as the 1 by R minus 1 by G, where R is the gamma d by gamma w. So at that point of time I will explain it again, because at this point of time, as per definition it is written over here, but the explanation is only understood when once you understood the some other test, synchrometer and specific gravity test. Over there the WS content, that how the change in volume takes place. At that point of time we will also discuss the volume of solid never gets changed, only the change in the water content result in the change it, like the WS, weight of solid, is always remain constant, volume of solid is also remain constant. Now some other definition, that is the plasticity index. Plasticity index is nothing but the liquid limit minus plastic limit. Liquidity index is nothing but Wn minus Wp. Now question is, what is Wn? So the water content in the present condition is Wn, and Wn minus Wp by Wl minus Wp is the liquidity index. Ip is nothing but Wl minus Wp. Similarly, the relative consistency is W1 minus Wn by Ip. So over here the one index is missing, that is the consistency index, right? The consistency index is nothing but WL minus Wn. WL is the liquid limit, Wn is the water in at this point of time, that is the natural, and divided by Ip. So we will discuss the problem on that in this class. Now, see the soil classifications based on the plasticity index. So the plastic, if the plasticity index is 0, it is said to be non-plastic. If it is less than 7, it is said to be low plastic. For the plasticity index lies between 7 to 17, the medium plastic. And if the plasticity index greater than 17, it is said to be highly plastic soil. Okay. Similarly, for the consistency of the cohesive soil, the liquid to be consistency is said to be liquid if IC is less than 1, and okay, over here there is one term, IC is the consistency index, while IL, that is liquidity index, and if it is both are converse of one another. So if we go on the basis of consistency index, it varies from 1 less than 1 to 0 to 0 0.25, 0 to 0.25 to 0 0.5, and so on. Conversely, the liquidity index is inverse of that one play. So these are the range which you need to keep in mind just for information, because sometimes the question is asked that for this much of consistency index, what is the description of soil? So over there you have to say that the soft or the hard or the very hard. That's right. Now this chart become very much important. I have said earlier also the liquid plasticity index equal to 0.73 into W liquid limit minus 20 is a interrelation. On this basis of chart A line, you can see on the basis of this chart only we can able to classify the soil, for specifically for the fine soil we classify on the basis of this chart, right? Now see, that the Indian standard soil classification system is based on the mechanical grain size distributions, sieve and the hydrometer, and the plasticity charts are used for this purpose. So the two-layer system, it is a two-layer system, that is whether it is a gravel, it is a sand, it is a well graded, it is a purely graded. It is also named as dual nomenclature is also given. So the two-layer system, what does it mean? The first one define the soil types and the second one define the subgroup. Example, SP state the poorly graded sand, while the SM state the silty sand. Over here you can see precisely that what I mean to say. So you see that the G is the prefix for the gravel, while the S for the sand, for the silt it is M, and for the clay C, for the organic soil it is O, and for the pit it is PT. But when you go across and interact with the problems, especially if I talk about problems, not about the actual field condition, you used to come across the gravel, sand, silt, clay, and organic matter only. When we talk about the subgroup, so it is well graded, and then TW poorly graded, P silty is M, clay E is C. And for the organic, liquid limit greater than 35%, low 35 to 50 is intermediate, and greater than 50 is less than 9. There is a little mistake over here, as I can see, right? There is a mistake over here. I need to rectify. This is not, this is less than. Okay, I will just state. You can see it later by yourself, right? So I will rectify it once I share the PDF. So the liquid limit less than 35% is low, 35 to 50 is intermediate, this is correct, and liquid limit greater than 50 is high. Okay, this you need to remember. I will change it once I share the PDF. So when we talk about the steps in the soil classification, so first of all, we determine whether the given soil is of the organic origin, coarse grain, fine grain. As I already said during the sieve analysis, I explained elaborately that how it is the coarse or the fine, depending upon whether the more than 50% particle retain on the 75 micron or less than 75% particle retain. An organic soil is identified visually by its color, brownish, black, or dark, and the characteristics order. If the 50% or more than soil particle by weight is retained on the 75 micron sieve, it is the coarse grained soil, and if not, it is the fine grained soil. I have defined very earlier when we see the sieve analysis, right? Now see, if the soil is coarse grain, obtain the grain size distribution curve. If you form the grain size distribution curve, you could able to find D60 by D10, that is the coefficient of uniformity, and D30 square by D60 into D10, that is coefficient of curvature. If again I will read over from here only, if the 50% of the coarse fraction from 75 micron is retained on the 4.75 mmc, classify gravel. If not, classify sand. I will not read it again, I will explain it. Suppose I will draw something. See, this is a container. Over here 4.75 mmc is there. 6 point. Okay, this is 4.75 mmc, and over here 75 micron. Micron understood by yourself. Okay, so if more than 50% particle are retained over here, but if 30% is over here, suppose 40% particle over here. Okay, I need a eraser. So over here the 40% particle is there, 75 below the 75 micron, 40% particle cone, and over here 35% particle is there, right? If 35% is here, 40% is there, then it becomes 75%. So 25% particle retained over here, and in that case, it is the gravel fraction is more, so it is stated as gravel. But if at this place 25% and at this place 35% is there, then you classify it as sand. That's only difference which I want to state. Okay, now we move ahead. If the soil fraction passing through 75 micron cv less than 5%, this is also important, then determine the gradation of soil, calculating cu and cc. If the particle passing through, okay, where is my pen? So if particle passing through this 75 micron is less than 5%, then you calculate Cu and Cc from the grain size distribution curve. How? If grain size distribution curve is there, you can calculate D60 by D10, D30 square by D10, because 30% you put a line on a 30% and you calculate D30, you put a line on the 60%, you calculate D10, you put a line on 10%, you calculate D10. So you calculate the CuCC, and if Cu is 1 to 3, it is a well graded. If Cc is greater than 4, for gravel it is well graded. It is greater than 6%, it is well graded. So you can classify it as GW, SW, or GPS. Okay. Now, when if more than 12% particle are passing through 75 micron, as mentioned earlier, if more than 12% particle are passing through 75 micron, perform the liquid limit and plastic limit test on the soil fraction passing through 0.425 mmc. Use IS plasticity chart. That is nothing but this chart only, and on the basis of that you calculate 0.7. You find that liquid limit is greater than 0.73 into LL minus 20 or less than. If it is greater than LL minus 20, then it is classified as clay, and if it is less, it is classified as silt. That's only written over here. I think so. I will read it. That a plasticity chart, and it will classify at GM, GSM, or GCS. Right? If it lies between the 5 to 12%, 5 to 12% pass through 75 micron C, then the soil is assigned a dual symbol appropriate to its gradation and plasticity characteristic, that is SP, SM, SP, SC, GP, GM. Now, if the soil is a fine grain, determine the liquid limit and plastic limit on the soil fraction passing through the 425 micron sieve and determine the plasticity index. If the limit of the plot on the A line classify as silt, further if the liquid limit is less than 35%, classify as ML. I already said less than 35%, low 35 to 50% intermediate, and if more than 50% it is high. So if the limit on the plot on the A line classify as silt M, further if the liquid limit is less than 35% classify as ML, and if the liquid limit is between 35 to 50 classify as MI, and if the liquid limit is greater than 50 classify as MH. Now, you see, if for the fine grain soil only, if the liquid limit plots above a line classify clay as C hoga, this is C, not at the rate C. Assign the group symbol as CL, CI, CH, depending on the value of the liquid limit. If the limits plots is hatched zone, then CLML, basically the dual nomenclature is also there. And if the limit plots close to the A line or close to the liquid limit 35 or 50% line, assign the dual symbol. So I will show you advanced chart which I have prepared for myself at some point of time in the next class for this classification system. If there is any confusion stated even after the today discussion. If the soil has 50% of each of fines and coarse grain fraction, this is also the case that 50% is coarse and 50% is fine, then determine whether the coarse grain fraction is gravel or sand. Determine the liquid limit and plastic limit of the soil passing through 425 micron sieve. Determine whether the limits plots above A line or below the A line classify as C or M depending upon above A line it is C, below A line it is M. Based on the liquid limit classify as low IH. If liquid limit is less than 35%, it is a low. It lie between the 35 to 50, it is I. If it is greater than 50, it is H. Assign the dual symbol from the information obtained from the steps which is discussed over here. Now name it as the GMML, GMMI, etc. Now we come to the closing the today's session nearby. So the relative density is nothing but Emax minus E divided by Emax minus E mean. This is the relative density is used to classify the sand based on the relative density. If relative density is less than 50%, it is a very low. If it lie in the range of 15 to 35, it is said to be loose. Means up to 35% it is loose only. From the 35 to 65% it is a medium, and for 65 to 85 dense, while greater than 85 it is highly dense, right? So over here the things are closed as per content. Now I will ask small questions, I think so you can able to answer, and you can respond over here if you are aware, uh, and we will discuss in that manner and then close the session. If you are comfortable you can answer, and we will see that whether the question could be answerable from the today's session or not, right? Okay, so the first question is soil formed by the disintegrations of rock without transportation is called. Okay, so whether it is alluvial, colluvial, residual, or aeolian soil. So as I know, aeolian soil is transported by air. Okay, no problem. I think so. The time is also less, so I answer the question by myself only, and doesn't wait for your response. But if you are comfortable, you can write in the chat box as well. That's not the issue for me. I will see it later. Right. Okay, so the soil formed by the disintegration of rock without transportation is called the residual soil because it formed by at that place only, place where the parent rocks and the weathering of the parent rock takes place. Okay, now the next question is which of the following is a transported soil? Okay, answer already came. So the options are laterite, black cotton soil, alluvial soil, loess. So the options, correct option is alluvial soil. Alluvial soil are deposited by running water. Now the next loesses, we have read about loesses, if you remember, and I think so. The answer is very much well known to you, whether it is wind or water. Okay, so the loesses is a type of soil transported by, I think so, wind, right? Absolutely right. Now we move ahead. The next question say that the soil transported and deposited by the glaciers is called. Okay, we have not discussed it over there, but from the option only you can say that the marine soil is the option, aeolian soil is the option, glacial soil is the option, colloidal soil is the option. So marine soil is that which is formed near the ocean's bank. Aeolian soil is formed by the air, but the glacial soil is formed by the deposition by glacier. Hence, its answer is uh, glacial soil. Now, which of the following is an example of organic soil? So here option is laterite, peat, loess, bentonite. I think so. I have not discussed this content, but this type of problem is there in your assignment. Will be there in your assignment. So the option is peat. Peat we have discussed, and I have discussed the peat soil. Peat soil is organic soil. We have discussed, as I remember. Okay, now the marine soils are typically found in deserts, not possible. Coastal region, maybe. Hill slopes, I don't think so. River valley, I don't think so. So the correct answer for this question is the coastal region, right? Right. Now the next problem is that the major agents for the mechanical weathering of rock is. We have also discussed about the mechanical weathering for the sedimentary rocks. So the carbonation, frost actions, oxidation, hydration. As I know, the correct answer is frost action, and it is absolutely correct, right? Now move to the next. That is the residual soil are generally the well-graded soil, uniformly graded soil, more stable, less weather. So that's not the problem if you are not able to answer this question, because we have not discussed it as well. But the residual soil are the more stable because they form in the place. Basically, they form at the place where the parent rocks is there, so they are more stable with depth. That's why the residual soils are more stable in nature, right? Now next problem is which of the following is not an index property of soil? So I think so index property we have discussed, so you can easily answer. Shrinkage limit is index property, yes. Plasticity index is index property, liquid limit is index property, but cohesion is not there, because if you remember when we read the index property, sorry, when we read the index property, we have a graph like this. Here the water content is there, here volume is there, and the graph is like in this fashion, it's linear. So over there, over here shrinkage limit is there, then the plastic limit, liquid limit is there. So the term cohesion is not discussed over there at any point of time. Yes, this is the correct answer, right? Next question is the Atterberg limit are applicable only to coarse grained soil, organic soil, fine grained soil, or the all type of soil. So I think so you can easily able to answer that this is applicable for the fine grained soils. Next is the liquid limit is the moisture content at which, okay, we have seen now there is a uh, uh, in a slide we have made that liquid limit between liquid limit and shrinkage limit, then liquid limit and plastic limit, shrinkage limit and liquid limit. So over here the option is the soil changes from plastic to semi-solid, soil changes from liquid to plastic state, soil changes from solid to liquid state, or soil starts cracking. So the correct answer for this is the option number B, that is soil changes from liquid to plastic state, and this is discussed in the today class only. Next is the formula for the plasticity index. Plasticity index is liquid limit प्लस प्लास्टिक लिमिट नो बिल्कुल नहीं, श्रिंकेज लिमिट माइनस प्लास्टिक लिमिट नो, नॉट liquid limit minus plastic limit, correct, option C is correct, right? I think so. In very much in a slide, liquid limit minus plastic limit is the plasticity index, only one point is written. If you are aware during the class, this answer you could easily answer. Over here there is a lack of time, the time is going out, so the class may get turned off by itself also, that's why I'm going little quickly. Okay, the correct answer is C, right? Now next is, if the liquid limit of the soil is 45% and the plastic limit is 25%, the plasticity index is nothing but liquid limit minus plastic limit. So it is 45 minus 25, that is 20. Option A, right? Next is, in the shrinkage limit is the water content below which shrinkage limit volume doesn't change. As I remember, what are the option I don't know. Solid volume increases, no. Solid soil stops shrinking, right? Soil becomes semi-solid, no. Water starts evaporating. So option B is correct. All right. The specific gravity of soil solids typically ranges between. Okay, so if you are aware, the correct option is option B, because 2 to 2.8 hota hai, is the 2.65 we normally take if we don't know. So 2 to 2.8 is the correct option. But we have not discussed it today. But I think so you must be aware about this. That's not a very tough problem. Next question is, which of the following tool is used to determine the liquid limit of soil? So Cascade apparatus, hydrometer, uh, perimeter, sieve shaker. So I think so one name I have taken today as well, that is the Cascade apparatus. That is the correct answer. Next is the consistency index. IC is calculated by the formula. So consistency index is nothing but liquid limit minus W by plasticity index, that is the option number B, as I remember. Bilkul. Next is the unified soil. In the unified soil classification system, classified soil based on color and order. I think so you remember, from color and order we didn't classify particle size and Atterberg limit. I think so it could be organic content only, no. Shrinkage ratio, no. Particle size distribution, basically we do the particle size distribution, we plot the particle size distribution graph. On the basis of that we calculate D60 and D30 and D10. Apart from that, from the Atterberg limit we found liquid limit, plastic limit, so we are able to shrinkage limit, so we are able to find the plasticity index. On the basis of that we are able to calculate the A-line formula, that is 0.73 into WL minus 20. If it lie above, we can classify clay, below silt, and many more things which we have already discussed. So option number B is the correct answer. Now according to the IS classification, soil with the particle size greater than 4.75 mm is, I think so this is the very most easy problem of the today's session, that is gravel, because it is discussed many a time. Next is, which of the following symbols represent the well graded sand in the USCS? Well graded sand. Agar sand, well graded sand, so first name is sand, and well graded, then it is SW, right? Bombay. D. Next is a soil sample is classified as CL in USCS. It indicate CL. CL means low plasticity, and C is clay. So as I can say, it is nothing but option number A. The last three problem is coming up. The term ML is ML in USCS stand for ML. ML means low plasticity, but M is silt. So low plasticity silt. Option number B. Next is the coefficient of uniformity defined as D60 by D10. B, right? Next is for a well-graded soil, CU should be lie in the range of 1 to 3. Oh, I think so. There are wrong options are there and wrong answer is there. Please don't. Okay. Oh, CC is lie between 1 to 3. CU is greater than 4 for gravel, greater than 6%. Right. No problem. A soil having Cu equal to 2 and Cc equal to 1 is classified as poorly graded, right? Poorly graded. C, option C. And from here, we will end up the today's session. Okay. So thank you, everyone. We will end the today's session over here. You complete your assignment, which will be shared with you before the next class. And if any doubt is over there, we can discuss in the next class. From the next class, our content get very more interesting. Today, most of the things are the theoretical, so you might face some problem. But from ongoing classes, you feel more interesting. And I try to want to make the interactive session. So if you have some suggestions, you can tell me over here at this point of time that how we can make it more interactive, so that it will be helpful for both of us. So I can also learn from something from you, and you get more benefited. I try to keep more questions from the subsequent classes, the theoretical concept, which also very much important, but the questions with the more explainable things, which I feel more useful for all of you. So if you have some suggestions, you can share with me, or I will discuss. You keep your suggestion, and we will think about what are the best way possible through which we can make the session more communicable. So accordingly, we will discuss in the subsequent class, because it is already 5 going to 5:15. So I think we need to end up the today's session. That's okay for everyone.
Yes, sir. Thank you very much.
Okay. So
Thank you, sir.
see, thank you very much. See you in the next class. Wish you a very happy weekend. Okay. So now I'm ending up the today class. Thank you everyone for attending the session.